Hi, now we'll discuss about SR flip-flop to D flip-flop. That is, we're going to design D flip-flop by using SR flip-flop. So the basic concept behind this, the which flip-flop we are going to design, for that flip-flop we need to write the truth table. So for D flip-flop, we have written the truth table. From which flip-flop we are going to design? From the SR flip-flop. For that, we have written the excitation table. Third one is we have conversion table. So conversion table is the combination of truth table as well as excitation table. And if you see that this initial part, first three column is the truth table of the D flip-flop. And last two, since we are going to design D flip-flop by using SR flip-flop. So again, we have to find the value here so that we can express S and R in terms of D. So that's why conversion table is used here. And if you still someone of have doubt how to write the truth table of the D flip-flop. So in case of D flip-flop, always we need to keep in mind that Qn plus 1 is what? D. So since it is the transparent flip-flop, so whatever input we are going to give, that only is going to appear in the output. That discussion we have in the latch also. So whatever is the value of D, here if you see that same thing we have written Qn plus 1. This is the probability of Qn. It can be 0, it can be 1. So when D is 0, that time also same possibilities 0, 1. Here also same possibilities. So on the basis of that, we are able to write the truth table of this uh, D flip-flop. Similarly, if you see in case of excitation table, so already we have another lecture on this where we have seen how to write the excitation table from the truth table for the particular flip-flop. So here for the how to remember, if you see that here S, what is the value of the S here 0, 1, 0 and don't care. R is the mirror image of that. That is the don't care 0, 1, 0 like this. And just for the reference, I'm saying here we have 0, 1, 0 and that is the same here 0, 1, 0 and these both are 1, 1, then we have here don't care. And R is the mirror image of S. Like this also you can keep in mind for the remembering purpose so that direct you can write from here. Now we'll see in the conversion table, if you see that here we have S and R. So how we are going to write the S value and R value? So here combination is 0, 0, Qn plus 1. On the basis of this only we are going to write S and R. So 0, 0, when it is the 0, 0, S value is what? 0. R value is what? Don't care. So same thing we have written 0 and don't care. Second combination here we have 1, 0. So where we have to find 1, 0 is here. So when we have 1, 0, then S is 0, R is 1. So we have written S is 0, R is 1. Then we have another two combination when we have 0, 1. So we have to look here in the excitation table. 0, 1, S is 1, R is 0. So S is 1, R is 0. Last one is 1, 1. So here both are 1, 1. Then S is don't care, R is 0. So S is don't care, R is 0. Like this, we are able to form the conversion table. Once conversion table is completed, then we'll go for the K-map so that we can write S in terms of D and R also in terms of D, or if it is required means Qn also will be included. So now when we are going to make the K map here, so this D and Qn is going to become the input for the K map. So that two variables are here, D and Qn. So in case of K map or Karnaugh map, we know that how many variables are there. A square of that is the number of the square boxes in the K map. So here we have two variables D and Qn. So 2 square 2 is what? 4. So 4 square box K map is required here. So that's why in the K map, we have 4 square boxes here. Now, if you see that for our reference, we can write here 0, 1, 2, 3 on the basis of this literal combination. Similarly, here 0, 1, 2, 3 we can write. Now, you'll observe the conversion table here. So when S is 1 and when it is don't care, that is important for us. So when S is 1 here, so we look for these two combination. That value is what? 1, 0. 1, 0 means decimal is 2. That's why here mean term is written here 1. Okay, here in 2 box. Next you have don't care. For the don't care again combination is what here? D is 1, Qn is 1. So what is the value? 1 decimal is what? 3. So in the 3 box here we have written the don't care. Similarly, if you look for the R also, so there also similar concept we can use for the in case of R. So here again when R is 1, so for that combination is 0, 1. 0, 1, that binding equivalent in decimal is what? 1. So in the box 1 we have written here 1. Now when we have don't care, combination is 0, 0. So for that 0, 0, decimal is what? 0. So we have written the don't care here. Like this, we have written the all values combination in the mean term. Now we have to find the Boolean function for this. Now to obtain the Boolean function, we'll try to make the combination. 0, 0, we are not writing whatever value you are seeing here. Since this is the going to give us complement, so that we are not using. When it is 1 and don't care, that only we are using. So now you will make the pair of this 1 and don't care, that is box 2 and 3, mean terms 2 and 3 here. So here if you see that row wise common is D, column wise nothing will come common. So that's why here we have S equal to D. So for this equivalent is D. So we have S equal to D. Whereas K-map for the R, again we'll make the pair here. Now here row wise what we have common, that is the D dash. Column wise nothing is common, that's why we have written here R equal to D dash. Now this one, if you see that we have S equal to D and R equal to D dash, that's why D is given here directly to the SR, S input of the SR flip-flop. This is our SR flip-flop. And this one is the clock pulse. And we are considering positive edge trigger clock pulse. That's why bubble is not here. So D is given directly to S. Since we have D equal to S from the K map, and complement of D is given to the R. Since we got R equal to D dash. So now finally we have here Qn dash. So here S and R is not function here for the Qn or Qn dash. Only we have D equal to S. Another is, or you can say in other way, S equal to D. And here we have R equal to D dash. So for that we have used the inverter. So like this, we are able to design D flip-flop by using SR flip-flop. And important thing is here how to write the truth table. So which flip-flop we are going to design, for that we'll write the truth table. From where we are going to design excitation table, and finally conversion table, followed by K-map. We'll obtain the Boolean function. That Boolean function we have to implement with the help of logic gates and flip-flop.